This is from a regional China math competition in 2023. It is a kind of preliminary round for the national competition. Here, we are given that log base a of x is strictly greater than tangent of x for x in this interval. We try to find the range of a. Of course, for the base of logarithm has to be positive and a is not equal to 1. When you see this kind of problem, you probably don't want to start with algebra immediately because there's no natural connection between tangent versus logarithm. However, you can use your knowledge about the graphs and maybe draw it out and do some reasoning. Let's do exactly that. We know for tangent x, for 0 to pi over 2 here, that's kind of the curve, is strictly increasing here. And of course, we're interested in the interval 0 to pi over 4. Pi over 4, of course, is smaller than 1, is somewhere here, right? So this is tangent x. And for the typical logarithm, in your mind, you should have this kind of curve where it's go to negative infinity as x getting smaller, and it's only be 0 when x equal to 1. Now, this is true, however, for log base 10. Yeah. So when you put the two curves together, you'll notice that it is impossible for the logarithm to be greater than tangent x with base 10, of course. So which means this base a must be something that will make the value between 0 to pi over 4 less than 1 here, and this blue curve somehow bigger than the red curve, the tangent curve. That's only possible if the base a is smaller than 1. When base a is greater than 1, the curve is going to be some shape like this, all right? But if you have base less than 1, you're going to flip the sign. Why is that true? Now, in your mind, you should have change of base formula here. So we change to base 10, and when a is smaller than 1, log a is negative, and that will make the curve flip over. So here we go. Now, here, the red one is still the tangent x curve, and this is going to be for different value of a smaller than 1, greater than 0, that's going to be the curve. Now, also notice that when a is getting really close to 1, log a is close to almost 0, right? For the change of base here, when this a is getting really close, smaller than 1, but really close to 1, this is going to be tiny value, and this value is going to be huge, right? So that is, when a is getting really close to 1, you can make sure that this green curve, for example, is always above the red curve and between 0 and pi over 4, right? So what is the boundary here? So in other words, a cannot be too small. When a is too small, you may have the blue curve here, portion of it is greater than the tangent, but some is going to be under the tangent, right? In order for the whole thing to be above the tangent, the red curve, you want to make sure that as a boundary, that is pi over 4, they exactly equal the intersection point, right? So that is, what is the boundary value for a? We know that a must be smaller than 1. It's desirable for a to be closer to 1, rather closer to 0. So what you do is you plug in the boundary value for the pi over 4 here. It must equal, the two curves equal to each other. Tangent pi over 4 just happens to be 1, so a in this case would be pi over 4. That's the boundary. So the solution to the original question is the a has to be in this interval. Again, this mathematical intuition is important in solving this problem. You don't have too much algebra, right? What you need to realize is that in order for this to be true, a has to be smaller than 1. right? Now, in order for the interval 0 to pi over 4, which is the vertical bar here, that's x equal pi over 4. So you want the boundary point here. Now this purple curve is going to be the value where the log base a strictly greater than the red curve, which is tangent, right? For any other one, like for example, the blue curve, now only portion of it, is strictly bigger and some of it is smaller, right? So when a is getting closer to 1, and this value is going to be getting much bigger, right? And so that's why the desirable value for a is going to be the open interval from pi over 4 to 1. That's the solution. This is a well-designed problem because it requires mathematical intuition to solve it in an efficient way. Hope you enjoyed the video. Please like, share, and subscribe to the channel.